If you could magically transport a fire hose into space and spray a high-pressure stream of water directly onto the sun to put it out, you would get a terrible surprise. The sun wouldn't extinguish. It would actually burn much brighter. Water is made of hydrogen and oxygen, which means adding water adds physical mass. On a stellar scale, more mass creates a stronger internal gravitational pull. That extra gravity squeezes the core tighter, accelerating the reactions happening inside. Pouring water on a regular campfire smothers it. Pouring water on a star feeds it. This happens because our star is not on fire. A terrestrial fire relies on chemical combustion. Atoms in a fuel source interact with atmospheric oxygen, breaking and forming bonds to release heat and light. Without oxygen, the reaction stops instantly. Back in the 17th century, early physicists developed mechanical pumps to remove air from sealed glass jars. They proved that as atmospheric pressure drops to zero, a true vacuum is formed. As you leave Earth's atmosphere, that pressure disappears completely. Outer space is a vast vacuum. There are no free oxygen molecules floating around to feed a flame. Since the sun sits in an oxygen-free void, its blinding light and blistering heat are generated by a non-chemical mechanism hidden deep within its core. Chemical combustion is a relatively gentle process where atoms remain intact and simply trade electron bonds. Powering a star requires something far more violent. The sun operates exactly like a continuously detonating hydrogen bomb. It relies on extreme, localized force to smash entire atoms together. Positively charged hydrogen nuclei violently repel each other through electromagnetic force, bouncing off one another before they touch. To defeat that repulsion, the sun's massive gravity acts as a hydraulic press, crushing the nuclei with enough speed and pressure to force direct contact. When gravity successfully pushes those nuclei together, the strong nuclear force takes over and binds them. This triggers nuclear fusion, a reaction that yields far more energy than chemical fire. Deep inside the sun's core, extreme pressure forces 4 distinct hydrogen protons onto a collision course. Through a sequence of rapid, violent impacts, those 4 protons are forged into a single heavier atom, a helium nucleus. If you were to weigh the ingredients before and after this reaction, you would find a mathematical anomaly. The newly forged helium atom weighs exactly 0.7% less than the 4 original protons used to make it. That missing mass doesn't just disappear. As Albert Einstein calculated, mass and energy are interchangeable. The physical matter transforms directly into pure radiating energy. Because the sun is so vast, that tiny fraction adds up quickly. The core converts 4 million tons of matter into pure energy every second. This model explains why the massive explosion doesn't blow the sun apart. It is balanced by gravitational equilibrium, a self-correcting loop. If the core cools, fusion slows. Gravity compresses the core. This generates heat, speeding fusion up, pushing outward to cool it down. As this graphic traces, the energy generated inside that core still has to escape. A new photon gets trapped in the dense inner layers, randomly bouncing off other particles for hundreds of thousands of years, before finally reaching the surface. Meanwhile, the fusion reaction also spits out ghostly particles called neutrinos. Because they rarely interact with normal matter, they fly straight out of the sun at near light speed, passing harmlessly right through the Earth and massive underground detectors like this one. Eventually, the struggling photons break through the outer layers. They leave the dense plasma behind, streaking across the vacuum of space to warm our planet. When you light a match on Earth, you are watching oxygen atoms trade partners to release a small burst of stored heat. The bright disk in our sky is a colossal, high-pressure engine, sustained by the constant crushing weight of its own gravity. So if you ever tried to extinguish it with water, you would only be supplying it with more fuel. The warmth you feel on your skin on a summer day is the missing mass of a crushed atom, brought to life in a vacuum.